Hey everyone, and welcome back. Before we begin here today, please make sure that you like and subscribe because it really does help out our channel. And it also helps us reach others in need of assistance with these topics. So today we'll be going over Calculus Part 4, derivatives of polynomials, and we'll be calculating the derivatives for these two expressions shown on the screen here. Now, what we've been doing and what we will do in this video is that we have been solving derivatives that are of this variety, where we have our derivative being taken with respect to x. We have a constant a times our variable x to the power of another constant b. So these two shown up here are not in terms of this expression, or not like this expression. So we have to turn them into that. But we'll get there. Taking the derivative of ax to the b is done as such, where we have our constant a remains constant through the derivation. X, our variable right there, to the power of b. And then we are going to drop that power of b in front and multiply everything by it. And then we're going to change that power by reducing it by 1. So essentially what we have here is b times a times x to b minus 1. So let's go ahead and let's apply this derivation technique. And starting with number 1, where we are taking the derivative with respect to x, d dx, of 1 over the square root of x. Now, it is definitely not in this term just yet, the ax to the power of b, but there are a couple of ways that you can get there. One is very long-winded, and I'm going to show you. And then one is the fast method, because in life, you always get the longer expression before you can get the quick expression. Am I right? So let's do it that way. So before we can take the derivative, let's go ahead and change 1 over the square root of x two different ways. We're going to do the first one, and then we'll do the second one, and we're going to try to get it in this form of ax to the power of b. So looking at this, whenever you have 1 over a variable, that basically means it's to the power of -1. So 1 over the square root of x is the same as square root of x to the power of -1. Well, the square root of any value is taking it to the half power. So what we have here is x to the 1/2 power and then to the -1 power. Anytime that you have a power to another power, you're just going to multiply them. So we would have 1/2 times -1, which would give us x to the -1/2. That's the long way to do it. Now we are in terms of ax to the power of b, where a is 1, x is still a variable, and the b is the -1/2 power. Or you can just look at this expression knowing that this is true. 1 over x to the 1/2 power. Well, just like what we did before, you take it up to the -1/2 power when you flip it like that. Either way is fine. This was the much faster derivation method to get to that ax to the power of b form. Does not matter which way you do. Sometimes it takes a little bit longer than others. So let's rewrite this as d dx, our derivative with respect to x, of x to the -1/2 power. Now we are in terms of ax to the power of b. Our a is just 1. Our power of, well, we have our variable x to the -1/2 power. We're going to take that -1/2 and drop it in front. And then we're going to subtract 1 off the power. So what we have going on here is -1/2 times 1, which is -1/2, times x to the -3/2, because 1/2 minus 1 is -3/2. And you could write it like this and leave it like that. Or you could write it like this, where we have minus x to the -3/2 all over 2. Same expression, just depends on how you want to write that answer. So that's how we do the first one. The second one, we are taking the derivative with respect to t, not x. So just exchange t in this expression for x. So we have ddt of the square root of 2 times t. So let's write this one out. So d dt of the square root of 2 times t. So once again, we have to put this in terms of ax to the power of b, which it currently isn't. So we can rearrange using fantastic math skills of square root of 2t is essentially 2t to the power of 1/2, because square rooting something is taking it to the power of a half. And anytime you have a variable with a constant to some power of n, that is essentially the constant to the power of n times your variable to the power of n. So we are going to have 2 to the 1/2 power times t to the 1/2 power. And then since the 2 to the 1/2 power is essentially just the square root of 2, I'm just going to leave it as the square root of 2 instead of writing it out. Doesn't matter. It's just a constant value, so you can leave it as square root of 2. If you want to write it out in decimal form, that's perfectly fine. So now I actually have this in terms of ax to the power of b, where a is my square root of 2, t is my variable that I'm deriving, or I'm taking the derivative of, and then 1/2 is my b. So we will have our constant square root of 2, the variable we're taking the derivative of, or with respect to, and then we have our power of 1/2. Take that power of 1/2 and multiply it in front, and then subtract 1 from it. So what we have here, if we simplify terms, we have the square root of 2 over 2 from the 1/2 times t to the minus 1/2. And once again, you could leave it like this, or you could write it like this, where we have square root of 2 over 2 times the square root of t, because this portion right here of t to the minus 1/2 is essentially what we did up here in the very first part. We just did it in reverse, where it's 1 over the square root of our variable, and that's what we have right here. So with these polynomial derivatives like this, a lot of times what you're going to have to do is you're going to have to turn them into that expression, or in the form of that expression, of taking the derivative of a times your variable to the power of b. And it just takes a little bit of math to get to that portion. But once you get to that portion, taking the derivative is as simple as it seems here. So I hope this video was helpful. And if you want to see more problems solved of this variety, please check out the other videos on our channel. Also, if you haven't done so already, please make sure you like this video and subscribe to the channel. Thank you for watching, and I hope you have a wonderful day.